Hi, Chem 102. It's Kaylin.
It's Julie.
It's Kylie.
And Tia.
And we're 3 elementary education majors and 1 graphic arts major, here to inform you of a brief overview of geothermal energy. What is the first thing that comes to mind when you hear geothermal energy? Think in your head.
There is a ton of heat trapped under the earth that can create a great amount of energy, and with it being renewable, there is not a long-term worry of it running out.
The word geothermal can be broken down into 2 parts, geo meaning earth and thermal meaning heat.
Humans have enjoyed geothermal energy from hot springs for thousands of years.
The energy is accessed through drilling water or a steam well. This is exemplified in the following illustration.
This image illustrates an example of accessing geothermal energy. In step 1, you drill a hole down into the earth until it reaches hot water. Step 2, the water comes up to the surface of the earth and it changes into steam. In step 3, the steam turns a turbine. This turbine is attached to a generator that contains a magnet. This magnet then turns due to the energy from the steam. This creates an electrical current. This electricity created can be put into a grid to produce electricity for many other people.
The cooling tower cools down the previous water that was used. This water then gets injected back into the ground. This water can be put back into the ground or in special occasions put back into a system such as the Blue Lagoon. As many of you might know, the Blue Lagoon is a natural spring in Iceland.
There are 3 different types of geothermal power plants. The first type is dry steam plants. These use steam from geothermal reservoirs to turn generator turbines.
The second type is flash steam plants, which is the most used type of geothermal power plants. They take high-pressure hot water from inside the earth and turn it into steam to turn generator turbines. Then after the steam cools, it is condensed back into the water and injected back into the ground to be used again.
The third type is binary cycle power plants. In this type, heat is transferred from geothermal hot water to another liquid. The heat that is produced causes the second liquid to turn into steam, which is used to turn generator turbines.
Now that you've been given a brief background on geothermal energy, we are going to play this video for you. This video gives a more cohesive approach on the understanding of geothermal energy.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses 2 types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
Now we're going to talk to you about the cons of geothermal energy.
Electricity is still needed to operate heat pumps.
In extreme cases, geothermal power plants can cause earthquakes.
There are heavy upfront costs associated with geothermal power plants and heating and cooling.
Geothermal power is only sustainable if the reservoirs are properly managed.
Geothermal energy using wells requires an incredible usage of water.
Now on to the pros of geothermal energy.
It is considered environmentally friendly.
The reservoirs are naturally replenished, so they are renewable.
Geothermal energy is great for heating and cooling, even for small households.
Harnessing geothermal energy doesn't involve any fuels, less cost fluctuations, and stable electricity prices.
It also leaves a small footprint on the land.
Geothermal heat pumps work year-round, unlike solar or wind power.
And recent technological advances have made more trusting resources and have lowered costs.
And here are some fun facts about geothermal energy. It is projected to be an industry worth $30 billion by 2020. The oldest spa that gets its water from a hot spring is considered to be a stone pool located at Lisan Mountain in China. It is believed to be built in the 3rd century BC. The first geothermal plant was set up in 1904 in Italy. This geothermal plant still produces power as of now. Geothermal energy's amount of electricity is less than 1% of the total electricity produced in the United States. Geothermal energy is widely used in California with more than 30 geothermal power plants that are producing more than 90% of the geothermal electricity in the United States.
California is the leading producer in the United States for geothermal energy. This is because of the faults located along the coast of California. Faults, volcanoes, hot springs, and geysers are all common sources for geothermal energy. But even with California, the United States is not a leading producer in geothermal energy. These nations generate the most geothermal energy based on their percentage of total power produced, not including fossil fuels or other renewable resources. Iceland produces 30%, Philippines produces 27%, El Salvador produces 25%, Costa Rica produces 14%, and in 5th place, Kenya produces 11%.
Now we can go over some main points to take away from this lesson. Geothermal energy is produced from the heat that is trapped under the surface of the earth. Geothermal power is accessed by drilling into the earth. There are 3 different kinds of geothermal power plants. The first is dry steam plants. The second is flash steam plants. The third is binary cycle power plants. There are many pros and cons associated with geothermal energy. Iceland produces the most geothermal power. We hope this video provided you with a better understanding of geothermal energy.
Thanks for watching!